Hello and welcome to this video in the R Analytics course. In the previous video, we had seen how to create a data frame, selection of rows and columns from a data frame through various methods, etc. In this video, we will look at more functions related to data frames. Let us import a table first. For that, we write read.xlsx. It is not appearing here because we have not installed the xlsx package. To check for it, we scroll down to see if it is installed or not. We see that the package is installed but the tick box is not checked here. To do that, we can either do it here manually if we are working in the R Studio, or write library and then xlsx in brackets and press enter. We can see now that the package is ready to be used. Now when we write read.xlsx, we see that it is showing in the list. In the brackets now, we have to mention the file path. We copy the file path from here and paste it within brackets. Remember to convert all slashes in the path to forward from backward. R can read only forward slashes and not the backward ones. After pasting the path, we have to mention the sheet in which the table is. We give it as 1 here. We save this table that is being imported in the variable sales. Now when we execute sales, we can see the whole table in front of us. Rather than viewing the data in the console like this, let us view it in a table by using the view command. The moment we write view and sales in it, we can see the table on top over here. Another option is to go to the environment window and then select on the symbol on the right hand side to view the table stored in sales. The moment we click on that icon, we can see the view command appearing in the console as well. Let us clear the console for now. In the last video, we had seen how to filter data based on rows and columns. One method was the subset method. We write A is equal to subset, followed by the name of the dataset sales as the first argument, and then we write select equal to followed by the columns we want to extract. As we execute this command, we can see we get all the observations for columns, month, sales manager, and quantity. The other method we had seen was where we used square brackets. We write B is equal to sales and in square brackets we put a comma. Remember, if we have written nothing to the left of comma, then it means we want to extract all the rows, and after the comma, we write columns 1, 2, and 4. Now when we execute B, we get all the rows but only columns 1, 2, and 4 as expected. Another way to extract a column is to write C is equal to sales and then in brackets sales followed by a $sign and the name of the column we want to extract. Now when we execute C, we can see that we get the data for dealer only. We can change this to get records for those values of quantity which are greater than 50 as well. We did this in our previous video too. However, when we work on big data sets in the corporate world, we do not use these functions. Instead, we use packages in R. The best package to work with on tables is DPLYR. Let us install the package first by going to the install button over here. We write the package name and we can see that the package is getting installed. Please ensure that the internet connection is good at this point of time. We can see here that DPLYR is installed. Now when we click on the tick box, we can see that the package is ready to be used. The functions we will look at under DPLYR are select. This helps us select columns from a given data frame. Arrange. This function helps to sort data in a table. Filter. As the name suggests, we can filter the given dataset based on some condition. Distinct. The function helps in finding out unique data or values. Mutate. We create a new column using this function in an existing table. Transmute. This is similar to mutate but with a minor difference. Summarize. Group by and pipe operator are some other functions under DPLYR that we'll look at in this video. We will see the uses of each one of the functions now. We write select, then in brackets sales, which is the name of our dataset, and then after the comma, we have to write the names of the columns we want to extract separated by commas. For example, here we write month, dealer, items, and quantity. As we press enter, we get the desired output. We must make sure that we write the names of the columns in the correct upper or lower case as defined in the table. As we can see, using these functions in DPLYR is very simple. In case we want a series of columns, say from month to quantity, then we can write it like this. Colon is the symbol for range in R. Upon pressing enter, we get the data for all the columns we wanted. Next up, we look at arrange. As mentioned earlier, this function will help us sort data. Now data can be sorted both in ascending and descending orders. We write arrange and then in brackets we give the name of the dataset, which is sales. Then we have to tell R that on what basis we want the sorting to happen. It may be based on any of the column headers. For example, we want to sort the data here by months. As we press enter, we see we get an error. This is because the letter M in month was written in small case. Once we correct this and run it, we get the desired output. April has come first because by default, R sorts the data from A to Z. What if we want to sort the data first by month and then on the basis of dealers? For that, we will write arrange, in brackets sales, followed by month and then dealer. So R will first sort the data by month and then it will use dealer as the basis to sort the data within each month. Till now, all the data has been sorted by default. How can we sort the data given to us in descending order or say Z to A? To do that, we write arrange followed by the name of the table. Then we write DESC desk for descending and then in brackets we mention the variable based on which we want to sort the data. We can see here in output that quantity has been sorted in descending order. Let us see another case where we want to sort first on the basis of item and then on the basis of quantity. For that, we first select just these two columns. We can save this in the variable D. Now D is a table which has only two columns, item and quantity. Now we will arrange our variable B based on the variable item. We can see the output is as expected. As mentioned earlier, what if we want to sort the data based on multiple variables and that too, some of them are descending and some are ascending? For that we write arrange, sales, month, dealer, and then DESC, quantity. Let us observe the output carefully. Firstly, all the records have been arranged from A to Z based on month. Then, within a particular month, say December, the dealers are sorted from A to Z. Then, within one dealer, like Gupta Book Depot, the quantity has been arranged in descending order. Similarly, we can observe for other months and other dealers where the sorting has happened accurately as per our requirement. This is how we sort or arrange data in R. The next function we look at is filter. Filter helps us select the rows we want, much like select helps us extract the columns. In Excel also, we use filter to extract certain rows based on some conditions. We write filter followed by the table name and then the condition on which we want to filter, which in our example is where we are putting item equal to pen. We can see in the output that only those records are in front which cater to the item pen. Another example we can look at is where the quantity we want is greater than 50. For that we write filter, sales, and then quantity greater than 50. We get 88 records from 153 in the actual table which have quantity greater than 50. This is how we use single condition in filter. For multiple conditions, we use two operators, and OR. Now we want to filter the data based on two conditions. Item is pencil and quantity is greater than 50. The output we get has only those records where item is pencil and quantity is greater than 50. The ampersand sign is used for the AND operator. Another example we can see is where we want the quantity to be greater than 50 and less than 80. So we have seen two different examples for the AND operator. Basically, we use the AND operator when we have multiple conditions and all of them should be true for all the records. The case where we want that the item can be both pen or pencil, then we use the OR operator. So we write filter, sales, and then we write item equal to pen, followed by the symbol pipe or vertical bar, and then item equal to pencil. This symbol is available on the keyboard on top of enter. As we press enter, we get an error. This error occurred because we typed the equal to sign only once by mistake. We had seen in an earlier video that in R, if we have to mention something equal to the other, then we have to type the equal to sign twice. Now we get the correct result where the item is either pen or pencil in all the records. We may add as many conditions using the AND and OR operators as we see here. Now we will see that how can both select and filter functions be used together. The case in front of us is that we want only three columns from the data frame: sales manager, item, and quantity, but only for the item pencil. So we have to select the three columns and then filter them based on this condition. One way to do this is to select all the three columns first, store them in a variable, and later we can filter the data of that newly created variable based on item equal to pencil. This is the manual method of solving this problem. We write E is equal to sales and then give the headers we want to extract. We then filter the data from E, where we put the condition as required, and store this in the variable F. Now when we execute F, we can see we get the desired output. Can we do this kind of a task in a simpler and quicker manner? We write select because that is what we want first to happen. Whatever we want later, we will write that in the end. We will then use the filter function. In brackets, we write sales and then item equal to pen. If we understand this code till here, then we have filtered our data set by pen, and now we will mention the columns we want to extract with the help of the select function. Please remember that in the select function, we have to first mention the data set from where we want to extract the columns and then the column names. So here we have the data set defined using the filter function, and then we mention the columns which are item and quantity. Basically, we have filtered the data first and then selected the columns from the filtered data set. As we press enter, we can see we get the perfect result. We have used the method of nesting two functions together here. The next function we look at is mutate. This function helps in creating a new column. The new column we want to generate is the target for sales next year, and we define it as the double of the existing quantity figures. We write mutate followed by the name of the data frame. We then mention the name of the new column we want to create, which is target, and then put it equal to twice of quantity. As we press enter, we get these values. Let us save these in the variable named new data. We can see here that a new variable with 153 observations and 8 variables has been created. Now when we view this data set, we can see it has all the variables of the sales data frame, including the new variable target. All the values in the last column are double of what were there in the quantity column. In subsequent videos, we will look at mutate in depth, where we will learn how to create a new column based on some conditions. Similar to mutate, we have another function, transmute. We write transmute followed by sales, then the name of the new variable we want to create. Say we put it as TGT and equate it to twice of quantity. We then store it in a variable TM. Now when we view TM, we get the new variable TGT only and not the whole table as we did in case of mutate. This is the basic difference between mutate and transmute. Mutate gives us the whole table with the new variables, whereas transmute gives us the new variable only. We will look at other functions in the next video. Thank you.